We've talked about compounds as opposed to mixtures. Mixtures have varying composition, and the particles in them are different. And so if you mix sand and salt together, you have a mixture. There are sand particles and salt particles. A compound is formed from different elements, but they are bound together in a particular way, and they have a fixed composition. Most of the stuff we run into, the matter, which is like anything you can touch, is a compound or a mixture, not an element. It's very rare to find free atoms of elements in nature. So the compound has a fixed composition. The mixture can have a varied composition. Important distinction.
I have a question.
Yes?
What about iodized salt? Is that a mixture as the iodine is added?
Iodized salt would be a mixture because it's sodium chloride with some sodium iodide in there as well. So, good question. So here's two illustrations. This just cracks me up because when I shared this with my other class, I was looking at this picture and, maybe I'm biased because my son's been working the packing house and he brings home lots of fruit and then, you don't manage to eat all of it and so it gets fuzzy after a while. And so I'm looking at that thinking, that looks like a moldy pear. Why is... And then I realized, oh no, that's a water balloon caught on film in the act of breaking. I just stood there for the longest time trying to figure out what that was a picture of. So here we have two balloons. They both have hydrogen and oxygen in them. This one, though, has a mixture of hydrogen and oxygen. Hydrogen gas and oxygen gas. There are different particles. You could have more of one and less of the other. You can vary the proportions. This weird-looking water balloon on the right has water in it. Water is composed of hydrogen and oxygen, but they're in this fixed ratio of 1 oxygen to 2 hydrogens, and all the particles are the same. This is a compound. This is a mixture. The distinction is, is kind of small, and yet it's really important to be able to identify that difference. So this concept was originally stated back in the early 1800s, and it's summarized in the law of constant composition. All samples of a given compound have the same proportions of their constituent elements. So pure water that you isolate from the King's River has exactly the same proportion of oxygen and hydrogen as water that you would get from the Nile River in Egypt or the Amazon in South America. Okay, it's exactly the same. All water molecules are the same because they are a compound. We can talk about mass ratio. If we take 18 grams of water and we decompose it, one way you can do that is by passing electric current through it and causing a chemical change. You can get oxygen gas and hydrogen gas. And you measure that, you're going to get 16 grams of oxygen and 2 grams of hydrogen. So we could look at the oxygen to hydrogen mass ratio, the ratio of the mass of oxygen to the mass of hydrogen. So 16 grams of oxygen to 2 grams of hydrogen. That gives a ratio of 8.0, or 8.0 to 1. So for every 8 grams of oxygen, you're going to have 1 gram of hydrogen. And if you decompose samples of water that you got from different places, it would always be that same ratio.